Hello, my name is Matt Hamilton. You probably know me as Hamato on Twitter. This is just a hopefully quickish video about the XRP Ledger, and a question that's often asked on Twitter about, is the XRP Ledger a blockchain? Asked is probably the slightly more polite way of putting it, but anyway, here we go. So on Twitter this week especially, there was somebody on there that was saying, you know, why would you even support a cryptocurrency that has a CEO, isn't decentralized and can't even be mined? And they then go on to say towards the end, you know, is it even a blockchain? So a lot of things here to unpack, but let's just talk about the idea of mining and about what a blockchain is first of all. So looking at a blockchain, so there's two key aspects of a blockchain, two key roles of a blockchain. Now remember, the whole point of a blockchain is to try and operate something in a decentralized manner. So a lot of things that would be very easy in a centralized manner. So you want to do payments. You have a central database. This is what the likes of, say, Visa or your bank these days generally are, a centralized database in which if you make a transaction, it's recorded on there and everybody can look in that central database. The idea behind a blockchain is to distribute that so that there's no one central authority. That makes it more resilient. It means you don't have to trust one central authority. So there's two key aspects of a blockchain. One is agreeing upon which events are legitimate in the first place, and the other is providing a tamper-proof record of historical events. These are two completely separate roles that happen within a blockchain, and let me just talk a little bit about them. So first, agreeing which events are legitimate in the first place. So we're talking about cryptocurrency here, we're talking about finance, so we need to agree that if I spend £20, I've spent it once, and I can't then re-spend that same £20 twice. Digital currency, they're ones and zeros, they can be easily copied, so it would be very easy for me to pay Alice £20 and pay that same £20 to Bob. How do we make it such that I can't double spend? Now that was one of the first things that Bitcoin managed to do. The big revolution in Bitcoin was using a blockchain to be able to solve that double spend problem. The second point is providing a tamper-proof record of historical events. So a blockchain allows you to be able to say with certainty that I paid Alice that £20, and there's no way that Alice can come back and say, hey, you know what, that £20 last week, yeah, you never actually paid it to me. So we can go back and say, no, look, there is a record of it, I did do it, and there's no way that I can change that, or that Alice could change that, or you know, anybody else, Bob or Charlie or Dean, can go in and change that record to reflect a different version of events. So in the case of Bitcoin, which is the blockchain that most people are familiar with, the way in which legitimate transactions are deemed legitimate is through a system called proof of work. I don't have time to go into the full details of this, but just to say that proof of work, the idea, if you make something non-trivial to do, then it makes it harder to forge, right? So if you can be sure that if something took some appreciable amount of time to do, that not just anybody could have done it. There's some more bits to that, but that's sort of a very basic analogy. So if I gave you a £20 banknote, you would probably look at that and know that it's a £20 banknote, because actually forging a £20 banknote would be difficult, right? In the same way that if I gave you a lump of gold, you would know that that's probably, you know, a legitimate lump of gold, because for me to go out and actually try and mine a lump of gold is actually very difficult, and so you know that it is legitimate. Being able to copy just ones and zeros is very easy, so how do you make sure that that transaction is legitimate? Proof of work is one way. It's the way that Bitcoin and a lot of the Bitcoin derived currencies, Litecoin, others like Ethereum as well, agree that something is legitimate. There's another way in which you can do it, which is what the likes of the XRP Ledger by Ripple and Stellar as well, which is similar technology, use, and that is instead use a series of validators. So if I were to give you a banknote and you asked 100 people, is this a legitimate banknote? If at least 80% of them came back and said yes, then you'd probably believe them. So it doesn't matter how difficult or easy it is to forge that banknote if you can actually ask a number of people, is this really a legitimate banknote? So that's what happens in the case of Ripple. instead of proof of work, you actually have these validators. Now the interesting thing being is I don't have to actually trust each individual validator. I just need to be able to trust that there's enough of them that I can ask that they won't collude together to defraud me. So if I ask 100 people, is this a legitimate banknote, I don't have to trust that one or two of them might actually give the wrong answer in order to you know, maybe game the system or defraud me. As long as I know that actually the chances are that, you know, 80% of them are going to agree, because it's going to be very difficult to try and get 80% of them to collude to come up with a single wrong version of events. If you think about a lawyer in a jury in some sort of case, they would ask a witness and they would ask several witnesses, and the point being is that they know that actually it would be very difficult for a whole number of witnesses to try and come up with one single coherent falsehood. That it's more easy to come up with a coherent truth than it is a falsehood, and they're all going to come up with different versions of events, and you probably know it's false. So that's what validators do. They just agree that the events happened, and they agree the ordering of events. So if I paid Alice £20 and I paid Bob £20 at exactly the same time, it's really easy if everybody can agree that I paid Alice first. If they can agree that I paid Alice first, then they know that I couldn't have then spent that same £20 with Bob. As long as everybody agrees that, then that becomes much easier. The second aspect is a tamper-proof record of historical events. So this is the bit that people think of when they think of a blockchain, a chain of blocks. So what is a blockchain? So looking here, these are a number of ledgers on the XRP Ledger, which are, you know, otherwise known as blocks, and on other blockchains. Some slight technical differences, but the concept is the same. So each one of these ledgers contains a series of transactions. There's then a hash, a fingerprint, a signature that is made of that. That hash is then included in the subsequent block, and then the hash of that is included in the next block, and you end up with this chain of blocks. And it then becomes a case that you can't tamper with one, because if you tamper with one, that would invalidate the hash. That hash is then would be different, would be included in the next block. That block is then invalid because the hash that is part of it has then changed, and so forth. So the knowledge of the error would propagate. So you can go back and validate. And you can actually see behind here, this is on GitHub site, you can actually see the XRP ledgers opening and closing. So every 3 seconds, 3 or 4 seconds, a new ledger is opened. You can see the number increasing here, and you see a number of transactions. So, you know, 20, 30, 40, 50 transactions per ledger that go through most of the time. And you can see the individual transactions and their payments of different currencies between different accounts that are going on here. So that's the point of a blockchain. It's a series of blocks. Each one is signed such that you have this chain that is non-tamperable, and that's being used in all sorts of things, not just digital currencies, but if you think about things like something like medical records or property records, you'd be able to go back and say, okay, that person did own that property at that particular point in time, and we know that nobody could subsequently go back and alter it and say that actually you know, somebody else owned it, because in doing so would invalidate the whole chain. The difference between XRP and say Bitcoin in this case is an XRP ledger contains the entire state. So all million or so, whatever it is, accounts on the XRP ledger, it has the entire state at any time. So if you start up a Bitcoin node, it would have to go back and fetch all of the previous blocks in the blockchain right the way back to the start in order to be able to verify everything and start to be able to give you answers. Whereas in the XRP ledger, you don't need that. You can just take the last few ledgers and you can immediately start answering questions. So starting up a XRP ledger node is much quicker than a Bitcoin node. So, but that's the main difference. But they do the same thing. They are both a series of records of transactions, each one that is signed, and then subsequently the hash is included in the subsequent ones. So that's what a blockchain is. As I said, you can see here, this is a view of it on GitHub for the XRP ledger, and you can see the transactions going through. Similarly, on their own Ripple site, the XRP charts site, you can see the payments go through, and you can actually click and see any one of these transactions, and they're all public records. So you can go through here and see that in this case it was some what was it? It was a Chinese an offer for some Chinese yuan in exchange for some XRP. So somebody's willing to pay some XRP in order to get some Chinese yuan on there. Stellar, very similar technology, same sort of thing as Ripple. They have very few transactions that go through the network in comparison, sort of, you know, 1 or 2 for every ledger, rather than sort of 30 or 40 that go through. But it's the same sort of thing on there. Stellar works in the same general architectural way as Ripple does, in that you have a series of validators. There's nothing more centralized or decentralized between them. They work in the same capacity of the series of validators that you can choose who you want to validate the records, and you just need to choose a set. In Ripple terms, they call it the unique node list, and that's a set of nodes that you think are unique enough that they will not collaborate together to defraud you. So there we go. Hopefully that clears that up. And going back to start here, is the XRP Ledger a blockchain? Yes, it is.